Welcome back. So far in this section, we learned about the event time and created tumbling window aggregates using the event time. We also learned about the watermark and state cleanup. In this video, I'll talk about the sliding window aggregates and create one example to help you understand the mechanics of implementing them. So let's start. Let me define a simple scenario and related requirements. Suppose you are collecting readings from a sensor. The sensor emits a reading at a regular interval, which goes to a Kafka topic. Each reading looks like the following JSON message. The key is the sensor ID. Created time is your event time, and the reading is the value. This could be a patient monitoring system where the sensor is attached to a patient measuring vital value. It could be a sensor attached to an engine of a machine measuring some parameters. Whatever it is, you are now asked to generate an output that looks like this. The first two columns are the start and the end time. The third column is the max reading value which you received in the most recent 15 minutes. What does it mean? Let me explain. Let's say you are monitoring patient temperature. So you are asked to report the maximum temperature in the 15-minute window. So when we say the max temperature is 36.5 at 10 am, it means you received some temperature readings from 9:45 to 10. But the maximum observation was 36.5. Make sense? However, you are also asked to report the outcome every 5 minutes. Now, let's think about the solution. You will immediately start thinking in terms of a tumbling window of 15 minutes and a trigger time of 5 minutes, right? Your first window starts at 9:40 and ends at 9:55. You got your readings and the maximum reading was 36.2. So far, so good. What is the second window? It starts at 9:45 and ends at 10. Wait a minute. This is not a tumbling window. Tumbling windows has got two properties. Fixed size, but they are non-overlapping. But in this case, windows are overlapping. Let me show you a pictorial representation for the same. Here it is. So my first window starts at 9:40 and ends at 9:55. The max reading in this window is 36.2. Similarly, the second window starts at 9:45 and ends at 10. The max reading in this window is 36.5. Both the windows are of fixed size. They are 15-minute windows, right? But they are overlapping for 10 minutes. And such windows are known as sliding windows or sometimes hopping windows. If you look at the first window, it starts at 9:40. But the next window is also a 15-minute window which slides or jumps by 5 minutes. The next window again slides by another 5 minutes. Make sense? Sliding windows are an excellent tool for computing moving aggregates. This example is asked to generate a moving maximum for a 15-minute window, continuously moving by 5 minutes. Such aggregates are also popular as sliding window aggregates. So you can also read the requirement to compute the max reading in a 15-minute window, which is continuously sliding by 5 minutes. Make sense? Great. Now let me also add some events to this diagram. Let's try to understand the sliding window aggregates using these 8 events. Now if you look at the first window boundary, we received only one event in this window, which becomes the maximum. Now look at the second window boundary. You currently have 2 events in this window. The maximum value is 36.5, right? Similarly, the third window has got 3 records and the maximum is 36.8. How many records do we have for 10:10 to 10:25 window? 3 events, right? And what is the maximum? 37.5. You should also notice one more observation. Each event could be part of more than one sliding window. For example, 36.8 event is part of the 3 windows. 9:50 to 10:05, then 9:55 to 10:10, then 10 to 10:15. And this is different than the tumbling window. In a tumbling window, each event could be part of one and only one window. Why? Because we do not have an overlap there. However, in a sliding window, each event is most likely to participate in more than one window due to the overlap. Great. Implementing a sliding window is exactly the same as the tumbling window. All the learning about watermark and state store cleanup also applies in the same way. Let me create the code for this requirement. Here is my example project. I'm creating a Spark session. Then I'm defining the schema for my input records. Then I'm reading my stream from Kafka topic and extracting the key and the value. Then I'm also fixing the timestamp. You already learned all this, right? Now this is the place where I'm capturing the aggregates. We are setting 30 minutes of the watermark. So all my windows which are outside of the watermark will get cleaned, and Spark will ignore all the late coming records for those windows. Then I'm grouping it for sensor ID and a time window. This looks the same as we created tumbling window, right? The first argument of the window is the event time column. The second argument is the window duration. Finally, we also have a third argument, which is the slide duration. And this third argument is the only difference in the sliding window. Rest all is the same as the tumbling window. That's all. Once we have a grouping, we can simply compute the aggregates, right? Finally, I'm formatting the output record and sending the output to the console. Done. Do you want to run it? Let me start the Kafka server. Create a topic. Start the producer. I'm going to send all the inputs at once. And that's perfectly fine because we are processing records at the event time. No matter you send it now or send it one by one after starting the application, your end result is the same, right? Let me run it. Here is the output. If you want, you can compare it with the following diagram. It is the same as we expected. Great. That's all for this video. See you again. Keep learning and keep growing.